Alright, good day everyone. So welcome back to my YouTube channel, which is Kasaligan Vlogs. And today we'll talk about hypergeometric distribution. So what is hypergeometric distribution? So let us define first hypergeometric distribution. A set of n objects contains k objects classified as successes and n minus k objects classified as failures. So sample size in n objects is selected randomly without replacement. So this one without replacement, take note that this hypergeometric is appropriate possibility for sampling without replacement. For n objects where k is lesser than or equal to n and n is lesser than or equal to n. So this is the formula. So let the random variables x denotes the number of successes in the sample. Then x is the hypergeometric of our variable. So this one, f of x, is equal to kx n minus k and n minus x over n combinations of n. So we could retranslate this one as k combination of x times, we have here, we can have this one as n minus k combination of n minus x over n combination of n. So we can translate this formula into a combination form, which is k combination of x times n minus k combination of n minus x and combination of n. So this is the maximum. The x is the maximum, 0 to the minimum. So the expression Kn is used to definition of the range of x because the maximum number of successes that can occur in a sample is smaller than the sample size. So take note of this one, that the number of successes that can occur in a sample is smaller than the sample size. And the number of successes available is k. So take note, and this is the sample size. K is the number of successes available. So also if n plus k is greater than n, at least n plus k minus n successes must occur in the sample. It should be noted that this is a combination b, so this is the formula, is a number of parts, or this one is a taken b at a time. So we have here a taken b at a time. So the hypergeometric distribution is appropriate possibility for sampling without replacement. So again, k taken x and n minus k taken n minus x, or n taken n. So therefore this one is k combination x. We can multiply this one as a n minus k combination of n minus x and n combination. So take note, hypergeometric is appropriate for without replacement. Alright, so we have here mean and variances, or variance of hypergeometric distribution. If x is the hypergeometric random variable with parameters n, k, and n, then mean is equal to, the mu is equal to the expected x is equal to n times the p. So we have here p is interpreted as a proportion of the success, okay, of the set objects n objects for high geometric random variable, the expected ex is the similar as the mean of the binomial random variable, or the expected. Also differs from the result of binomial variable only by the term shown below. So the term in variance hypergeometric variable n minus n is called the finite population correlation factor. So how to get the variance of this one? So by the use of the formula np, 1 minus p, n minus n over n minus 1. So where p is equal to k over n. So this is how to get the mean and the variance of the hypergeometric distribution. Okay, let's try this one. Given that x is a hypergeometric distribution with n is equal to 100, n is equal to 4, and k is equal to 20. So determine p x is equal to 1. So p x is equal to 1. So by the use of the formula, we have here k, n. So we have here n minus k, this is big letter N, and n minus x over, we have here n taken n. Okay, so the the given here is our k is 20, so we'll just substitute 20. And what is our n, which is 4? Okay, so this is deduction. N minus k, so what is our n is, we have here 100. And what is our k, which is 20? And n minus x, which is our n, 4, minus, okay, 1. Over, what is our n over n? We have here, n is 100, taken 4. So we could write this one as 20 combination of 4 times, what is 100 minus 20? That is 80 combination of 3 over 100 combination of 4. If we're going to multiply this one using calculator, so the result would be 20 combination of 4. So over, this one is 0.4191. So this is the answer. So px is equal to 1, that is 0.4191. So this is for p is x is equal to 1. So let's proceed with p is equal to 6. Okay. So they have here p x is equal to 6. So take note, the same formula with this one. We'll just substitute here with the formula. What is our k? Our k is 20. And what is our n? Our n is equal to, okay, so since our n is equal to 4, and take note of this one, so we have here, next is n. What is our n? Here is 100. Okay, minus the k, which is 20, and n is 4 minus 6 over, we have here 100 taken 4. So take note, 4 minus 6, it will create a, a negative. So why is it a negative? So therefore, the possibility here is when x is equal to 6, and take note our n is 4. So the sum, since the sample size is only 4, so we could say that there is an impossible probability. So this is 0. Okay? So n is equal to 4. So take note, we have to take note of this one, that the maximum number of successes that an core is smaller than the sample size. So it should be smaller than the sample size. So it is impossible probability, or 0, if that is it should be smaller than the sample size. So since that is greater than the sample size, so therefore this is 0. Immediately this is 0, or impossible probability. Okay, so let's proceed with letter C. Letter C is x over 4. Okay, x is equal to 4. Okay, so we will rewrite the formula k n, small n. Okay, this one is n minus k n minus x over n taken n. So in the given, we have here I will write k is equal to 20 and x is equal to, okay, we have here 4 and we have here uh, n is equal to 100 and then n is equal to 4. By substitution, we have here k, that is 20, taken n, which is 4, okay, times n, this is n is 100, taken minus 20, taken n minus 4 minus 4. Okay, so we have here n, what is our n? 100 taken 4. So by the use of this one, 20 combination of 4, and this one is 80 combination of 0 over 100 combination of 4. By the use of the formula calculator, so we have here 20 combination of 4, 80 combination of 0, and over 100 combination of 4, the answer is equal to 0.00, 1, 2, 3, and 6. So this is the answer for letter C. Next, we have here, find the mean and the variance of x. So take note, let's recall. So this is the mean and the variance of x. So this is the formula how to find this one. Okay, by the use of this formula, for the mean, expected x is equal to np, where n, what is the value for our k? K is equal n is the value for our p is equal to k over taken n, I over n rather. So k over n, that is equal to, what is the value for our n, which is 4, times what is our k? K is equal to 20 over 100, which is our n. So by the use of calculator, we could compute now the mean. The mean is 0.8. So if we're going to look for the variance is equal to Vx equals np 1 minus p, then n minus n over n minus 1. So we have here, what is our n? Our n is equal to 4, rather 4k, and our p, how to get the p? The p is the number of successes. Since we have here, our p here is how to find for the p. To find for the p, p is equal to k over n. So what is our k over n? We have here, k is 20 over n, which is 100. So therefore, 20 over 100, that is equal to 0.2. So what is here? So we have here, what is our n? N is 40, 4 rather, times 0.8, no, 0.2, and we have here 0.8, and we have here, what is our n? Our n is equal to, okay, our n is equal to 100, minus n smaller, which is 4, over n minus 1 is 100 minus 1. So by this calculator, we have here 4 times zero point 0.2, 4 times zero point 0.2 times zero point 0.8 times, this is 100 minus 4 is equal to 96 over 99. The answer is 0.6206. So this is the answer for our variance, and this is for our mean. So again, this is how to find the variance and the mean of the hypergeometric. Okay, so let's proceed with question number 2. A lot of 75 gaskets containing 5 in which of the variability thickness around the circumference of the gasket is unacceptable. A sample of 10 gaskets is selected at random without replacement. So take note it's on without replacement. What is the probability that none of the unacceptable gasket is in the sample? So in this A, our x is equal to 0. So we are going to have the formula. So Px is equal to Kn, Kx other, Kx times n minus k over, taken x, n minus x over n taken n. So in the given here, what is our n? Our n is equal to k. What is our n in the given? Our n is equal to 75. Our n is equal to sample 10. Our x is equal to 0. Okay, another one. So our k is equal to 5, contains 5. Okay, so our x is equal to 1. So by the use of the formula, kx, so k, what is our k is 5, taken x which is 0, times n minus k, what is our n? 75 minus 5, taken n is 10, taken 0, over n is 100, taken 4. So by the use of the formula here, so 5 combination of 0 times 70 combination of 10 over 100 combination of 4. So what's the answer? 5 combination of 0, 70 combination of 10 over 100 combination of 4. So therefore the answer is 0.4786. So this is when P is equal to 0. So next is at least 1. Okay, at least 1 of the acceptable gasket is in the sample. Since we need to have at least 1, so starting with uh, 1 up. So included 1 up, starting with 1. So therefore, if that is at least 1, so we have here P. P is x is greater than 1. X is greater than or equal to 1. So that is the complement event. So how to get the complement event? 1 minus the probability of x sub 0. So if we're going to get the probability of x sub 0, so therefore 1 minus x sub 0 is the at least 1 unacceptable gasket in the sample. So we have here 1 minus, what is the probability of x is equal to 0? By the use of the answer for number letter A. So we have here 0.4786, or shall we say 0.5214. So this is the answer for set number 2, or letter B. Next is exactly 1 unacceptable gasket. An acceptable gasket is in the sample. So exactly 1. So P x is equal to 1. So by the use of this formula K, which is 5 taken 1, then we have here n minus k. So n 75 taken k, which is 5. Next we have here n, which is our n is 10 taken 1, over, we have here the total is 75, rather this is k75 combination, this is 10 rather. So for this one again, let's recall with number 1. So this is 5, uh, 5 combination of 0, 75 minus 5, 10 minus 0, 75 combination of 10. Okay, 75 combination of 10. So let's recompute. Okay, by the use of our calculator. So we have here 5 shift combination of 0 times 70 combination of 10 divided by 75 combination of 10. Okay, 4786. That is 75 combination of 10. And this one in number 2, 75 combination of 10. So by the use of this one, 5 combination of 1 times 70 combination of 9 over 75 combination of 10. So by the use of the calculator, so we have here 5 combination of 1 times 70 combination of 9 equals divided by 75 combination of 10. That is 0.3923. Okay, 3923. So 3923 when X is at least one acceptable gasket is in the sample. So the next question is find the mean of the unacceptable gasket. So how to find the mean? Expected X is equal to, to find the mean, we have here NP. Okay, NP, to find the mean is N and P. So what is our N? N is equal to 10. Our P is equal to K over N. K over N, which is 75. So by the use of calculator, we have here 10 times 5 over 75. Or we can cancel out immediately. Or we have here 2/3. Okay, 2/3. Or we can have this one as uh, by 5. Or we can multiply 10 times 5 over 75. That is equal to 2/3. So that's it for number 2. Okay, let's proceed with number 3. Of 50 manufactured steel rods in the production process by a company, 12 have defects. If 10 steel rods are selected at random for inspection. Find the probability that exactly 3 of the 10 have defects. So exactly 3 of the 10 have defects. So first, we are going to find for what is the formula. So let's again, the formula is P of x is equal to k over x, taken x times n minus k taken n minus x over n taken n. So first is we need to find for the value for k. What is our k? K is we have 12 defects, so 12. What is our n? Our n is equal to 50 because this is the population. And what is our n? Our n is equal to, okay, 3 out of 10. So 10 still right, so 10. So we have here, our first is find exactly the probability of x. So our x is equal to 3. So p x is equal to 3. So by the use of this one formula, k 12 taken x which is 3 times 10 minus we have here k 12 minus 12 minus k which is uh, n which is n is 50. Okay, this is 50. Okay, 50. Well, I write this one as 50 minus our k here is 12 taken which is our n 10 taken 3 over n is 50 taken 10. Okay, so we have here 12 combination of 3 times 50 minus 12 that is equal to 38 combination of 7 over 50 combination of 10. So by the use of calculator, we have, okay, 0.2703. And next problem is find the mean and the variance. So how to find the mean? So mean EX or the mu x or equal to n times the p. What is our n? Our n is equal to 10. Our p is k over n, 12 over n which is 50. So therefore we have here 10 times 12 over 50 that is equal to 2.4. Okay, so this is the mean. How to get the variance? The variance, the var x or this one, symbol for this one. So n p times 1 minus p, then n minus n over n minus 1. Okay, what is our n? Which is 10 times 12 over 50, then 1 minus 12 over 50 because 1 minus 12 over 50, and this is 12 over 50. What is it got here? 12 over 50. The formula is k over n. So this is just the complement. So therefore 1 minus p and q. So therefore this one is our q, or we can have this one as our q or 1 minus p. Then times, what is our n? Our n is 50 minus our n is 10 over, we have here 50 minus 1. By the use of calculator, we could derive this one as, okay, 10 times 12 over 50, then times 1 minus 1 minus 12 over 50, then times 40 over 49. The answer is 1.4890. Okay, 1.4890. Oh no, not 90, 1.890. Sorry, that's okay. That's exact. Or that is the rounding off. Okay, so we have here tried this at home. So a large bin contains 80 balls, of which 30 are red balls and 48 blue balls. So 15 balls are picked at random. Find the probability of getting 4 red balls. The mean number of red balls and the standard deviation of number of red balls is sample is picked with replacement and without replacement. So take note, hypergeometric is applicable appropriately to without replacement. Suppose a box contains 5 red balls and 10 blue balls. If 7 balls are selected at random without replacement, find the probability that at least of 3 red balls will be obtained. So thank you so much, ladies and gentlemen, and everyone for watching these videos, and I hope you learned something out from my discussion about hypergeometric distribution. Thank you and God bless.